Okay, everyone, because our time is so constrained, so we haven't our coffee break. If you need, please go outside to bring by yourself. Now, I would like to announce our another session, satellite communication facilitator for IoT-supported water applications. In fact, for my personally, I'm not the expert of this topic. And when Nina told me that if I can co-chair this session, I said, yes, I can do some homework. So in fact, I found some materials and now I'm standing here. Because maybe a lot of us, also like me, not very familiar with these topics. Before our speakers begin their presentation, I want to share the concept of these sessions. The satellite communication also means a satellite Internet of Things. It refers to the use of satellite technology to facilitate communication and data exchange among IoT devices located in remote or inaccessible areas. If we can focus on the last of a few words, the remote and inaccessible areas, these kind of technologies will help us to communicate IoT and satellite, make the information more fluently. So our first speaker is from our Egyptian Space Agency colleagues. The title of her speech is Integrating Satellite. No, it is go to another one, sorry. Yeah, here. Supervision, agriculture, and water management resources through space-based IoT technology from our colleagues, Soumya Mohammed, please.
Good afternoon, everybody. It's my pleasure to be with you today. It is my pleasure to be with you today to give this talk about the IoT satellite or IoT technology. Our content. We give a brief introduction and our objectives, the background and methodology and result. I can discussion, a conclusion. You know, United Nations defines absolute water scarcity. It is if the person have less than 500 meters cube per person per year, it means there are a water scarcity. So in Egypt as well, we reached to 560, so we close to be water scarcity in Egypt. What is the effect of water scarcity on SDGs? The water scarcity effect on the agricultural productivity, so this reduce the crop and make a food insecurity, as well as water scarcity challenges urban sustainability because it makes cities struggle to meet water needs for growing of a population in these cities, as well as it will be affect on the industrial growth and consequently infrastructure and development of economic of the countries. Our objective, we need to address the water scarcity Egypt in our issue in our regions, then to to improve crop and resilience against climate change that affect on SDGs. We try to, in our project, to explore what is the feasibility to use IoT technology on monitoring of agriculture and water management. What is the background to do or to start this project? We as a developing country or emergency country, we have previous missions in the space technology, like Iot-Supported, NARS Cube 1 and 2. This is a cube satellites. Next one, MASSAT-2. All of these satellites is developed by the Egyptian expertise with cooperation with other partner. This satellites, it was for remote sensing. So we started from this point to we need to develop the IoT space technology by our hand. A methodology of to monitor the management to monitor the water management resources or agriculture, as Dr. Dries said in the first day in the workshop, through remote sensing satellites or from IoT technology. From IoT, from remote sensing satellite, we have our own satellite that that was launched in Q4 2023, and the NextSat-1 as well that launched in first quarter in 2024. So the next we need to integrate IoT technology with the remote sensing to monitor our resources. This is a sample from the images of MASSAT-2. This resolution, it was a 2 meter. IoT applications, there is a lot of many applications we can use IoT in it, like water management resources, agriculture and smart farms, maritime and fisheries, assist tracking of the countries, disaster management, remote infrastructure monitoring as well. You see, you can from satellite to manage all of the resources on the ground through you collect the data from these sensors that it's installed in different areas for different applications. Especially in water management resources, we can use the IoT in monitoring the water quality, supervising infrastructure and equipment of the water resources by sending notification from the system to its parameters, as well as enabling a smart irrigation based on soil state, weather forecast, irrigation calendar according to the sensors it installed in the smart agriculture. Each sensor gave me indication about certain properties or certain something I want to monitor it. IoT system design parameter. Here I will talk relatively to technology, not just on applications and results of the implementation of the IoT in the water management resources. I will talk about how we design this system to be useful or used to our application. So for any IoT based space system, we should have two parts for this system. One on the satellite, this is payload, IoT payload, and one on the ground station. This is set nodes or sensors. That is, I want to collect its data. Okay, so I have here some specs for the IoT payload on the satellite, and as well some specifications for the ground node or sensor in the ground node. Okay. After that, we take these parameters or this specification and we make a simulation on system design tool. Here, our design, it will be cover some cities in the North Africa and Middle East, okay? But the satellite can cover many areas according to its orbit and so on. This simulation, we need to know how many times the satellite will be path on the nodes on the ground to collect the data per day. Because sometimes some applications need more than one reading during the day. Sometimes we need one per day and so on. This is data link budget. I don't know. I don't want to go in depth in the details, but the data link budget, it will be calculated to know how many data I can collect it from all the sensors I will pass during the day. To know the numbers of sensors and which regions I can install in these sensors in these areas. Finally, this is the prototype or of the payload. The subsystem will be installed on the satellite. So this is after we make the simulation, we design the system and go to manufacture the subsystem to be installed on the satellite with this specification. The specification of this payload or this payload can be uploaded on cube satellites or remote sensing satellites, as well as it can be launched on a LEO satellite. The second part, it be the node on the ground. So the sensors on the ground can be communicate directly to satellite or through gateway. Like you see here, the satellite sends certain messages to the sensors network, or we can collect directly from the sensor. I mean I connect with the sensor, not mean temperature sensor, or no, I mean there is a node. This node connected with many sensors and collect from them certain data, and this node transmits the data to satellite directly, or through workstations. This workstation collect from many nodes, not only node. I want to play this is the video. I want to play the video. Okay. What I do. Okay. This is the simulation for the design payload for satellite. We here just launched one satellite. So this video show how the satellite will connect with the nodes in different cities during the only one path. You see? So if I put another cities to communicate with the satellite, it will be communicate according to the orbit. You see, this is the orbit of satellite. This orbit, the path of satellite during routing around the Earth. Finally, we can do this system. We can launch IoT space technology for remote for monitor the agriculture and water resources or any collected data from any nodes, any type of data. Our challenges in this system, we need to improve the power systems for each node on the ground, because mainly we need to use IoT space technology for a remote areas because this is there is no infrastructure for the internet or something like this. So we don't know we don't need to lose the monitoring of these areas. So as well, this is remote areas as well. We need to improve the equipment that is installed in there because we don't need to add overhead cost on the system. As well, we face a challenges to funding this project in the beginning, but it's now it's okay. As well as the arranging between different entities in Egypt to arrange their needs. And you know, in the beginning, everyone he or she needs collecting the data every day, many times, and that is not possible to do in the first phase of the project because the first light cannot serve all of these data. Finally, IGZA started to its mission in IoT. IGZA is our agency. Started the design, started to prepare for the preparation and design of this payload to be installed in satellite, in separate missions or in remote sensing mission. What does this mean? If I can provide this subsystem on Cube satellites to be launched to reduce the cost, or I can, if I prepare to launch a remote sensing satellite, I can put the IoT as a secondary payload on this satellite. So you can, with one satellite, you can get image formation, and as well you can apply IoT technology. Finally, we encourage any international collaboration with any institute or any research entity. They interesting in applications of IoT and so on. That's all.
Okay, thank you very much, Samaya, for your interesting talk about IoT connecting with satellite. And I think in your presentation, you have some key messages. The first one is showcasing how to integrate these two systems together. Another is that how to build these systems. And based on your presentation, we can looking forward that in the future, this kind of system may greatly improve our data communication, especially focused on agriculture sections. Yeah, thank you very much again. Because our time is so limited, I haven't leave time for your questions. I think our another speaker is online. I don't know if he is already there. Can you help to connect them? I think he is Zhao Yuan from France. Okay.
Hello. Did you see me?
Yes, we can see you. Because I haven't detailed information about you, so before your presentation, please make an introduction of yourself. His topic is water quality monitoring system based on the same technology, IoT and Earth observation. In his topic, he mentioned the nanosatellite constellation systems. I think this is a very new technology. Now the floor is yours, please.
Okay. I try to share my screen. Tell me if it works.
Not exactly. Yeah, it is correct now. You can start now.
Yeah, or you want to, you got my presentation, or you want me to share my screen?
If you can share, I think you can do it by yourself. Or we can do it.
Okay, so good afternoon, ladies and gentlemen, esteemed delegates, dear colleagues. I'm truly grateful for the opportunity to present at this United Nations conference on space technology for water management, a novel approach utilizing IoT sensor and Earth observation nanosatellite constellation system. So I apologize not being with you today, but do not hesitate to contact me by email if interested to develop new cooperations. So my name is Zaomin Nguyen. I'm the co-founder and Chief of Strategy and Innovation from the French startup Prométhée Earth Intelligence. To get the big picture from the topic, so just to remind that today, as has been said quite very often during that conference, that the world is moving and uncertainties are increasing quite significantly due to three main factors. First one, the world population has already exceeded 8 billion people and is trending towards 10 billion in the coming years. As 60% of the world population is concentrated in areas 150 kilometers from the coast, this puts strong pressure on resources. Increasing total global warming results in more frequent and more intense extreme drought and natural disaster, enabling a more vulnerable world. Third, our dependence on fossil fuels and the scarcity of resources has caused numerous geopolitical tension and conflicts. Within that context, water resources are facing a host of serious threats, such as eutrophication, plastic pollution, or pollution linked to illegal activities such as gold planning. Water is under extreme threats from a growing population, increasing demands of agriculture and industry, and the worsening impact of climate changes. In low-income countries, poor ambient water quality often results from insufficient wastewater treatment, while in high-income countries, agricultural runoff poses a more serious problem. The economic impact could be therefore significant, with a reduction from the economic growth that may reach a third in some countries. To give you a concrete example of what could happen, in France, end of last year, by Christmas period, all the oyster producers from the Arcachon area, southwestern France, were forbidden to sell their product due to the norovirus that came with the strong rains and an excess of water that could not be filtered by the wastewater treatment. This financial loss was estimated to 7 million euro, that clearly show how this could be a very strong impact based on the quality of the water. Now, today, IoT sensors enable ultra-precise local information, benefiting from hyper-responsive telecom infrastructure to become decision support tools. This information must be clearly transmitted in real time to an operational center. But we can see in the one hand that this information should be readjusted with regard to their geomorphological context in order to reduce the level of uncertainty as much as possible. This is where space and scientific models from Earth observation capabilities come in. Make it possible to correlate and merge all of this data to provide consistent and reliable products and services. On the other hand, you may see from the representation from the overall water cycle map that there is a strong dependence from the local and global and vice versa. And this is for that reason that in-situ sensor may not be enough to have a global understanding on the root cause from the water quality issue. In recent years, the deployment of long-term in-situ sensor has increased the temporal and spatial data being obtained. The development into remote sensing using satellite and aerial imagery has been incrementally integrated into catchment for monitoring areas that previously might have been impossible to monitor, producing high-resolution data that has become imperative to catchment monitoring. But with change that may occur almost any time, the remaining question is how to get real-time data from space technologies. And this is where new space technologies came. As a matter of fact, with one satellite, you have to wait 3 days to get the imagery from the same area of interest. With 20 satellites, you may have indeed one image every 45 minutes within European latitude, for example. This is why only deployment from constellation of optical nanosat on different orbital planes are enabling near real-time data. But let's start by present the case study with the Ether River located in south of Brittany in northwest of France. On that case study, we want to analyze our retention basin and wastewater treatment station may affect water quality during an extreme weather event. You may see on the picture 6 shellfish farms along 5 water retention basins and 2 water treatment stations. With a simulation of water levels rising by 2 meters, we may observe that the water from the retention basins can be drained into the river, and this may clearly affect the quality of the water of the shellfish farm. As you may see on the picture, this simulation is very close to the reality, since we can see on the bottom left that oyster farm was underwater by last November in 2023. So what we can simulate could be clearly not far from what is the reality, and not only in France. So the next step after is the preparation of the algorithm. For this, we use open source imagery satellite with Sentinel-2B from the Earth Observation European Program Copernicus, and we train the algorithm with AI based on the satellite imagery combined with in situ data for the estimation of the chlorophyll and the suspended sediment. With green and brown colors, we have been able to have a good view from the quality of the water. The goal is clearly to set up early warning system with reports, dashboard, and with an interface that may directly be used by non-space experts, directly end user through different digital devices. On the right side from the slide, you may see how the estimation of the chlorophyll and suspended sediment have changed during the year 2023. And if such kind of tool were set up by last year, we are quite confident that we have may save a lot of producer or oyster based on what with the norovirus, and avoid all this economic loss that I've mentioned before. On the near future, the IoT sensor will be directly interact with our 20 nanosat constellation called Japetus. Indeed, Prométhée Earth Observation is a French new space Earth observation operators. It means that we are developing our own space infrastructure, and the objective is clearly that enable that the sensor in situ can directly interact with the space infrastructure. Each time the pollution threshold will be reached, the information will make it possible to take the picture from the constellation of satellite, then providing real-time understanding with a global view. With our constellation, we will be able, in one hand, to improve the image resolution 10 meters to 1.5 meters GSD, and the number of images per day by 1 image every 5 days with Copernicus data to 1 image every 45 minutes. We will be able then, in one hand, to carry out permanent training of the algorithm in correlation with the in situ data. This will allow for better monitoring and more precise measurement with more granularity. In conclusion, harnessing the power of space technology combined with IoT sensor data offer us unprecedented opportunities to monitor and manage water resource with greater precision and efficiency. It's very important to have clearly this holistic approach for water quality monitoring, and combining this data clearly are key for the integrated water resource management system. Our Japetus demonstrator for the nanosat constellation is already in production, and we plan to launch within next year. And with onboard processing, this help for near real-time information. I'm deeply appreciative of the platform provided by the United Nations to share this innovative approach, which has the potential to revolutionize how we safeguard water quality on a global scale. I extend my heartfelt thanks to the UNOSA team and all those involved in organizing this conference. And together, let us continue to explore innovative solutions to ensure access to clean and safe water for all. Very happy to cooperate with all of you. Thank you.
Okay, very interesting presentation. Thank you very much for your giving us a very good cases about how to using IoT and nanosat together. And I think this study is, for me, the interesting is that it is really connected to the end users, and their technologies have been using as early warning systems. Because your time is controlled well, I would like to leave 1 or 2 questions to our audience here or online. Are there any questions? Yes, please.
Really great presentation. I have a question about this in situ data you are collecting for these algorithms you are developing. In general, water conditions tend to degrade sensors pretty fast. Which is the way you are addressing this in your work? Thank you.
Okay, so if I understood well, the question is what kind of or what kind of data I got from the in situ sensor, am I correct?
No, so it's about the degradation of the in situ sensors, because when you have sensors in water, they tend to degrade faster. If you are considering that, and how are you addressing that, the degradation of the sensors?
Okay, so as I explained, we combine two kind of information. One treatment is based on the directory algorithm based on the satellite imagery that can get some information, and the other one is the information from the same information like chlorophyll and suspended sediment directly from in situ sensor. The objective is clearly to take into account the gap between that kind of two information and try to correlate with an AI in order to improve the level of resilience and the level of discrepancy between the information provided by the satellite in order to be more correlated with the in situ data. And with this, with AI, we are able to decrease that uncertainty. In that case, try to avoid to use more satellite data than in situ data, because as has been mentioned, today the pollution of the water could be in place where you do not have any in situ sensor, and clearly the objective with that is enable us to get more confidence on the satellite information that are that will be correlated very often with in situ data. Do I answer to the question?
Okay, thank you. Is there any online questions? Oh, if no, thank you very much, Joe. And we're looking forward to see you next time on site. Thank you again.
I will do. Thank you. Bye-bye.
Now, let's move to our next speaker. He is from Peru and avid Roman. His topic is integrating satellite, drone, and in-situ sensor data for precision water monitoring and advancing cacao farming practice.
Good afternoon, everybody. Thank you very much for the presentation. So I will talk this afternoon about the integration, data integration from satellite images, drone images, and in situ sensor, apply it to the cacao farming. It's work. Okay, so as a context, which product Peru export to other countries? In the 1962, we can see we have cotton, sugar, copper, coffee, but we don't have cacao yet. Cacao doesn't appear. But in the 2017, yeah, cacao appeared here. Very, very small, but appear because the production of cacao is increasing in Peru. Cacao is becoming an important product in Peru, especially for reducing the coca farming. Yeah, in Peru, the idea is to reduce the coca farming and try to find other alternatives for the population. The main country where we export cacao is France. So we export considerable amount of cacao to France. And for this reason, farming cacao in Peru is critical. As I told you, the idea is to replace the coca farming by cacao. In Peru, the production of cacao is increasing in 15% in the last years. And we have cacao in different regions, but the main regions are Cusco, Ayacucho, San Martin, Junín, and Piura. These areas are regions that cacao production is big. As I told you, the idea is to use cacao farming to replace the coca farming in Peru. In last years, we recovered 56,000 hectares from coca to cacao. And the cacao farming is a very important economic activity for us. Okay. We propose to use satellite images, drone images, and in situ sensor to try to monitor the farming, humidity, wetlands, and to try to improve the farming activity. We will apply this proposal in Cusco, that is one of the important regions for cacao farming, specifically in Echarate, that is a small town that produces cacao. And also is a region that where we have gas, natural gas. So the city have some money to implement this kind of proof of concept. Okay, the idea is not only try to observe the farming process, but also adjacent areas that can have different ecosystems that could help to improve the farming activities. So we have in these regions the Vilcanota River that embed all the agricultural metrics in this region, and we can use them to characterize all the landscape connectivity that could be important for improving the farming activities. Okay, the methodology is using satellite images, drone images, and in situ sensor to try to monitor different aspects of the ecosystem, and we try to focus on the cacao farming. The idea is to use remote sensing data, extract some parameters from this data related to biodiversity indicators, to analyze temporal evolution of this indicator. And for using this indicator, the idea is to understand the situation of the area, our area of interest, and try to combine also with drone images, in situ sensor, and apply some artificial intelligence techniques to try to combine, to classify, and to understand the behavior of this indicator. The idea is to use deep learning techniques, convolutional neural network with different many layers, and to try to simplify the future extraction process, because The future extraction is a very critical step. So the idea is to simplify this step using a convolutional neural network, try to extract different kind of information and try to understand this information to characterize our area of interest. So we expect some result that can be helpful to our authorities for make some special decision. In terms of data, we use Landsat images. We can also use the Peruvian SAT images and combine with the Landsat images to try to improve the spatial resolution. In terms of in situ sensor, the idea is to use the LoRaWAN soil moisture and conductivity sensor. It is the model, and a drone with two types of cameras, multispectral and hyperspectral camera, and try to classify the images using neural networks. Okay, the idea of this proposal is to apply in Echarate in Cusco, as I told you. In this region, there are mobile data, so we can have access to internet. But in the future, the idea is to implement this kind of technology in other regions that maybe we don't have mobile data, we don't have internet connection. For this reason, together with the Peruvian Space Agency, we are proposing to have a communication satellite for Peru. Currently, we have a remote sensing satellite, PeruSat-1, but we are planning to have a communication satellite. To support the proposal to buy a communication satellite, so we are planning to use the communication satellite for different aspects, health, education, work, business. And in Peru, according to the National Institute of Statistics, we have 121 contracts related to telecommunication satellite services. So this is the tile of the contracts: satellite segments, telephony, internet, data transmissions, TV satellite, in total 121. And this contract represents 68 or 60, near to $69 million from 2015 to 2020. And with this kind of amount, we planned to try to calculate the benefits of buy a communication satellite in contrast than to have this kind of contract with private companies. So different ministers are involved in this contract. So the idea is to have a communication satellite to give these services to all these ministers, and not all, and to have a communication satellite will not only for cover this 121 contract, also to cover the other demands that exist in Peru, because we have many population that doesn't have connections. So our expected impact after applying this proposal is to increase the cacao export to 200 million, recover more hectares from coca to cacao farming, increasing 15% each year the production of cacao, and try to put Peru in the work as the main country of cacao production. So that's all. Thank you very much.
Okay, thank you very much, David. In your presentation, you make an introduction how to using a drone, satellite images, and soil sensors together to measure the condition of cacao farming. And I think this is the future potential using of IoT and satellite communications. I don't know if they have any questions here to his. Okay, please.
Gracias. Hello. Hello, Sam. Can you explain me what is the alternative use that you can give it to the coca plant in Peru?
So
Can you use this plant, for example, I don't know explain in agronomics, but can you use this plant as a natural pesticide or something similar?
yeah, in Peru we have an institution. It's called ENACO. That is the only authorized institution to buy coca from farmers. We cannot buy coca by ourselves. No, only ENACO, that is a national institution, can buy the coca. ENACO buy the coca and can produce how to say infusions or something like this. But of course, there are another coca production that doesn't go to ENACO, go to other site, and the idea is to try to replace this production with cacao.
Can any Peruvian or foreign visitor buy the infusions or tea packs or small packs in the market, in the common market?
Yeah, this kind of product is possible to buy in Peru. Yeah.
A quick reminder, please ask questions that are related to the subject matter of IoT and water monitoring. I'm curious to learn about the water quality conditions. How would water quality affected from mining, which takes place a lot in Peru as well, I think, affect crop growth of the cocoa?
Yeah, this is a trick topic because in Peru we have different regions that is dedicated to mining. Yeah, actually, my university, Universidad Nacional de Moquegua is a small city, but with big mining activities. But of course, Moquegua don't produce cacao. In region where we produce cacao, Peru, Ayacucho, Junín, San Martín, and Piura, we don't have many mining activities. So for this reason, cacao is producing in this region. So we found this kind of balance between mining activities in other region and cacao production in other region.
And do you think it's feasible to get the satellite purchased by the government to support your activities?
Yeah, I think so, because with the Peruvian Space Agency, we are preparing the proposal, and we already talked with the defense minister that is in charge of this budget to buy a communication satellite. Yeah. Thank you.
Okay, thank you very much. I think our time is up, so I need to make a brief summary. Then I hand over my floor to Nina, because we have another session. No? No, if no, I think I would like to open questions for our first speaker from Egyptian, because the time I did not leave question to her. For our Egyptians presentation. Do we have questions to her? Okay, also congratulations. So if for the your sessions, I will make after I make the summary, okay?
If there is any question for Glacier, we can also do that quickly, maybe one or two.
Maybe after.
Yeah, after my
Okay,
session,
yes,
okay. Yeah. Any question for my first speakers? If no, okay, please.
I have a question for the first speaker. I think that the work you're doing is amazing. I would like to know if the data that you are thinking of collecting with this network of sensors is something you want to make like public, and in that case, how are you going to distribute it, or is something that you are going to offer in a more private basis, like offering a service to certain people, if you are thinking on that?
Actually, the sensors that will communicate with this satellite, it should be with the same equipment or with the same transceiver on the satellite. So it will be installed at your own platform or own areas. So it will be useful for you only, not for all the public using.
Okay, thank you. Now I think it's my turn to give. Okay, another questions, please.
How many users can you support, and can you elaborate a bit on the various user types that you would provide these services to?
It's according to the rate of the collected data during the day. If the collected data will be one per day from each sensor, it may be around 300 or 400 per one transceiver. So our subsystem, it includes 4 transceivers. So you can collect from around 1,200 sensors, not sensor, but nodes, because the node connected with many sensors. So the data will be between the nodes and satellites. So 1,200 node. So each node maybe can connect or collect data from different sensors, like it's according to the type of data from this sensor.
Okay, thank you. Now I would like to give a brief summary about our session. Although we only have 3 presentations, but for me, I think they opened a small window for me, and then me in the future I can extend my research field to these regions, because we can also using these technologies to for our water resources topics. And I think only 3 presentations, but we, in fact, we have 3 research aspects. The one is agricultural water resource management. The second is water quality. And another one is cacao farming. So also this can reflect that these kind of technologies have greatly use potentials in the future. So this is a very good things for us. And finally, I would like to say thanks to all the 3 speakers and questions from our floor. Thank you for your time, and so thank you very much for joining us. Okay, and now I think I would hand over the phone to Nina.
Thank you very much, Shanlong Lu, for your moderation, and to all the speakers of the day who kept flexible and made the day successful in the end. After all, I think we had a really nice experience during the field trip, and we managed to get the sessions delivered despite the shuffling. I thank you all for that, and tomorrow we'll meet at 9 o'clock here, and the shuttle will pick us up at 8:30 as on the other days. Thanks a lot, and expect an exciting session tomorrow morning with a keynote by Professor Jim Nelson. more exciting speakers to deliver their presentations tomorrow. And then in the afternoon, we'll have technical closing sessions with briefings by the moderators with their conclusions and recommendations. Thanks a lot. See you tomorrow.